day advice. We left off tinkering around in this capture file, more or less just doing a tour of what I would call just tour of buttons in Wireshark. I'm guessing not that many folks have played with before. So I'll keep going along that avenue to see what all is going on. Most of the kind of cool information we get is from the statistics menu. And it's really all about figuring out what's really going on. So there's, like, depending on where you work, it's a thing to be given traffic traces like this and basically say, like, we need a report of what's going on here. We have this network traffic. We don't know what it is. So going and piecing together like what looks like normal stuff, and in this case it's all normal stuff. There's nothing like sketchy going on, but pulling all the pieces of information together is kind of a useful thing. So I think we left off talking about the endpoints thing, right? Like where we can see all the different conversations that are going on. And I think we even specifically talked about this particular one, right? For doing, whoops, not endpoints, we did conversations. That's what it was. And we talked about DNS stuff. So when we look out here, what could be relevant about tracking down DNS stuff?
What sites were used?
Well, we can figure out maybe what website someone's using. It's also a good way to track down malware if we see DNS queries, really crazy random looking things. So would it, because this is something very specific in this particular trace, do you think when you're looking at an average user's web traffic, are you just going to see a couple DNS queries going on? So what we have here is something really like, this would be suspicious if you looked and you saw just this. Because when you load dsu.edu, are you just loading dsu.edu? How can we do this? If I go dsu.edu, and then here, and then go here, I think. Maybe if we refresh the page. So these are all of the lovely files that we're pulling down just to load DSU's homepage. And then the other part is, if we look at the domains, like a lot of it's dsu.edu, right? A lot of the files coming from our website come from us. But then ajax.googleapis.com, what would you see a Google APIs request to for? It could be fonts. The other one is Google Analytics. Here's fonts. And then that's probably a Google Analytic because we're not actually selling advertisements off the DSU webpage. The doubleclick.net is going to be Analytics. There's actually Google Analytics. We load some YouTube stuff. So there's lots and lots of stuff that actually comes in. So based on this is kind of odd that we wouldn't normally see just someone going to www.dsu.edu. That's not normal. So if we wanted to actually track down DNS stuff, where could we find information? It's actually one of them. If we could just go to statistics and then DNS, this will pull up. What it's immediately concerned with is basically the performance of stuff. So if we have slow DNS server, something like that we're troubleshooting, this is a good way to go get statistics on that sort of thing. The other one is if like DNS can be a source of slowdown in a network. If we weren't caching DNS, why would you cache DNS, or who would cache DNS for you? Yeah, your computer's going to do some caching of DNS. Then the next level up, like if you're using DHCP to get those settings here at DSU, you're asking DSU, we have a set of DNS servers that are caching things. If you just use the defaults at home, you're probably asking your ISP. So your ISP is probably caching these requests too. So that when your ISP goes out and figures out an answer to a DNS question, it holds on to it for a little while. So this is where you can start to figure out like how deep did we have to go inside of here. The other one is if you're troubleshooting something, when you're asking a DNS question, you should expect to get a response, right? Or you should expect to get an answer. So Wireshark will actually go and chunk out like every DNS question that was asked, and it'll pair it up. Like, did we actually get an answer back from here? So, say if we look at the return code, so if we have DNS that's like flapping somewhere, if you're troubleshooting stuff on a network or trying to see what's really going on, it's going to be really, really hard to find, like, are there errors in DNS if you look through here manually? And we can tell that because if you go actually search for DNS and not just look at Google inside of here, you get a very, very extensive list of DNS packets that is very much so a challenge to look at because it just goes on and on and on. And case in point, like as we're down, like as far how far have I scrolled? Scrolling along, scrolling along, scrolling along. Still there, still there, still there. Yeah, right about here, I think. No, we're still loading DSU things. Keep going. Oh, it keeps scrolling me back up. That's why the scrolling is just never ending. Yeah, about somewhere in here. Oh, there's a web advisor request. Here we go. All of the packets from like as far down as I've scrolled are all just DNS traffic, DNS traffic to just load DSU's homepage. Our homepage has a lot less crap on it now than it used to, but it still has plenty of things. So troubleshooting DNS is kind of a thing, right? It's going to be the epitome of fighting with and determining what all is going on for network traffic. Any guesses at the next page that was loaded when I came down and found the end of the DSU stuff? What's the next one? Yeah. So if we go back into statistics, I don't know. This is a good way to figure out problems on a network too. So we can actually see over a period of time the I/O, the packets that are flying back and forth. And why do you suppose we'd ever want to look at TCP errors?
Errors usually tell you what's wrong.
Yeah, if there's packets that are coming in with problems, we want to troubleshoot it. There's a catch though. Any guess as to what type of network this was? Physical layer network? Especially looking at the rate of errors and how they burst up when the traffic rate's really high.
Wi-Fi or something?
Yeah, it's a wireless network. So we shouldn't see numbers like error rates this high on a wired network. It should be really low. But on a wireless network, the more packets you're exchanging back and forth, the more errors you're going to have. And that's just the way it is. We can come in and like take this guy and zoom in if we wanted to, and now I have to move over and drag it. If you want to do like super pinpoint things, which I don't know. But this again is like a good reset. Good way when we're sitting there capturing like a ton of data off of a particular area or particular branch of your network. Start to figure out like, yeah, this is a wired network. We shouldn't be seeing stuff like that. How can Wireshark find out if there's a TCP error? Yeah, so in Actually, here we go. Here's a couple examples. One particular option inside of here, and this is something that would be expected inside of wireless traffic. Inside of Wireshark, when you see red, the black frames with red text inside of it, that means Wireshark has determined like there's something wrong with this. In this particular one, it's received what it has determined anyway to be the same packet twice. So the wireless network retransmitted it. So it's like there's something wrong with TCP because it keeps retransmitting stuff. That's kind of what wireless does, though. If wireless isn't receiving confirmations in its sliding window that packets are being received, it's going to retransmit it. So that's one thing. There's another one. Sometimes, if we actually go into, I suppose it's in capture. Oh no. Nope, didn't want to do that. They've moved it somewhere. Well, anyway, some networks, actually, let's just find a real packet. This one, scroll down, checksum. It says validation disabled. Why does TCP have checksums in it?
Just the packet that's all messed up.
Yeah, it should verify whether or not the packet is like lost data or whatever. So it's a sort of rough hash of the packet to make sure everything's really okay. When you actually look at this checksum, that hex value, is that a very good hash, being how big it is? D00B? Not really. But it's a pretty good indicator. However, you notice Wireshark says validation has been disabled. Any idea why? Or does anyone know why that is? What's that?
Takes a lot more power.
Yeah, so that's one thing, is that it takes, doing the validation is going to take Wireshark a lot of work to actually check all this. The other one is, when you look at like the path that a packet takes, when it comes from the wire to like where Wireshark has intercepted it, there are a lot of good network adapters now do what's called TCP checksum offloading. So what that means is back in the day, when you would receive a packet, all your network adapter would really do is be like, is layer 2 safe? Like, does layer 2 look good? It would check to see the MAC address stuff looked good, check that it was its own MAC address, so it was supposed to receive the packet, and then it would pass it on up the line. So basically, back in the day, your network adapter lived at layer 2 and did nothing else. Your operating system handled the other layers of the OSI model. That's great, except for what problem does that, or not really problem, but what does that burden us with?
Yes, it burdens the processor with handling that.
Yeah, like the rest of your computer, the operating system, the processor, and everything, has to deal with handling, like calculating the checksum of every TCP packet that comes in. So back in the day, it wasn't really a big deal. When we get to the point where we're trying to send like 10 gigabit, like you can put a 10 gigabit network interface in a computer, or a 40 gigabit network interface, or faster ones that are even crazy fast, you're going to end up like having to have a CPU in your computer just dedicated to doing TCP checksums. Because the rate in which you're receiving packets is going to be so crazy that you just max out your processor. So good network cards will do all the TCP checksum validation at the actual network card. So basically, network cards are crawling up the OSI model and doing more and more and more. Which is why, I don't know, go...
How are they handling the processing load? Like, are they trying to, are they trying to handle it better by, creating ASICs and stuff
Yes.
like that?
There's usually a chip of some sort, like an ASIC, on the network card that actually does it. So, not knowing a model number off the top of my head. What is this? There we go. Here's a 4-port. Is this a 4-port gigabit? I'm guessing that picture's not right. Maybe it is. Let's look closer. A different angle. Huh. This must be for some weird blade thing or something like that, because the network ports are clearly facing the inside of the card, and I don't know why. But regardless, this is a $400 network card, right? I mean, this isn't a normal network card. Like, you wouldn't seek this out to put it in your desktop at home, right? But you'd go spend $400. You spend a lot more on a graphics card, right? So they're actually at the very top. The description provides TCP/IP acceleration. So what this card has on it is, and you can actually see, if we zoom in, it actually has heat sinks on it. Like, it actually has processors on board this network card that are doing things. So that's what separates good network cards from bad ones. Is good ones actually have some stuff on them. In the end, one of the things that will cause when Wireshark goes to start validating stuff is if the network card is doing the validation for you, it depends. Some of the cards will just like strip out the checksum value, because it's like saying, well, hey, I did all of this. There's no reason for me to pass those extra bits along. Or sometimes they'll just set them to all one thing, or they just monkey with the value sometimes. And if you open it up in Wireshark, Wireshark should be like, boo, this is all super broken. When really it's fine, the network card just did it for you. And so there is a checkbox that I was seeking out, but I can't seem to find inside of here for doing if I was playing with this particular one. So here, no. To disable checksum like offloading on the network card, so it'll let Wireshark do it all for you if you're having that problem. If you have like tons and tons of TCP checksum problems, what's the avenue to look at? It's probably like a bad piece of network gear somewhere. If you have frames that are like getting garbled a lot, so that can cause problems. It's actually like, I've spent part of my life before going around a network because we saw like there's just junk traffic coming, and seeking out, like, initially it was we're hunting down the perp, right? Someone's got malware in their computer and it's just spewing literally like just shit packets is literally what it was. Like packets that are getting across the layer 2 network that are just junk. It's just not, you'd open it up in Wireshark and Wireshark's like, whoa, beats me as to what this is. I see MAC addresses in there, but everything else is just broken. So I start paring it down. That's the cool thing about starred networks is you go plug in to a switch, enable a monitor interface, junk packets here. Nope, not this branch of the network. Keep going further and further down the line, and eventually found a computer where it wasn't like the perp. It was just a bad network card. Oh gosh, that car finally backed out. There's a car sitting over there that, like, its reflection in the windshield is, like, right in my eyes. And it's been dry. That's why I keep standing. Like, John's head was actually blocking the glare, so I kept shifting off to the side here. I guess that's the downside to having a sunny day. So anyway, yeah, if you wonder why I kept going over here and, like, kind of staring at John, it's because I was trying to hide from the glare of that car. So, anywho, that is our kind of rough checksumming stuff on what all that's doing. What's another good one? Well, the HTTP stuff is kind of fun. So, generally, what do you suppose the majority of the traffic on your network is going to be? It's mostly users doing web stuff, unless you're doing a lot of file share or something like that. So, breaking this out, this is actually a cool one to pull off a web server, because you can really quickly figure out, like, users are hitting. Now, there's obviously better reporting mechanisms. Like, I would probably take the logs off the web server to figure out if there's something broken on it. But from in here, if, let's say, someone, like, compromised the web server and you want to see what's going on, from here you can actually usually really quickly find this out, because if someone is beating on a web application trying to break it, what kind of errors are you suppose you're going to find in the network traffic? I mean, here we are. Here's our choices. I mean, there's just broke. You usually aren't going to see a lot of that. Usually the web server is going to reply with some kind of error code. So usually if someone's beating on a web application, like trying to compromise it in some way, you're going to start seeing 500s. So if you see like a 503 error, what could a 503 error be? Oh, jeez, no. So 503 is service unavailable. What that usually means is there's a web server that's like running PHP or like .NET code, and the actual executable on the server that's executing the code has crashed. So if someone's generating 5.0, and usually what the server is then supposed to do is when it sees, like IIS, when it sees its W3WP process crashed, it just restarts it. And normally we go on with life. But this is a really, really good way to find out what someone was doing to you. If you're seeing 503 errors, you can filter them down and just find, like, here's the TCP stream of traffic that generated that 503 error, and you can actually look at the data that they're sending to the server on their posts and actually see, like, oh, they injected this long string of data and it blew up the application. We should maybe look into that. Or, like, if they're doing, like, some kind of sketchy SQL injection kind of thing and the server's just kicking back a server error with it, you can actually find their strings that they're doing because it's just web traffic going on. So this actually, in the grand scheme of things, since most of the applications, when we see applications, that term used so much and love it, so we need an app now, right? Usually it's just a web page, right? Even when I always love, like, I don't know, the community center in Madison is now like, we've got an app. And really what it is just a crappy rendering of their web page, but it gives you an icon on your phone, right? That's like half the apps you use are just crappy web page renderings. Or even if they are actually pulling in data, they're usually using what to get the data? Some kind of, a web page or some kind of RESTful API or posting and getting JSON data back and forth. So, yeah, lots you can actually figure out here. Then, not too many other like radical things in my case because there's just nothing really going on. So, pulling out web information is always a good time. Is there any other cool statistic-y things for us to look at? I don't really think there's a lot. Oh, there should be a timeline graph. This is another good one of when someone's like, well, I have a Wireshark capture. I need to know what websites they went to. There are good ways and bad ways of doing that. A good way is to actually use Wireshark's HTTP thing, then start filtering this down. Because Wireshark will build you out the list, and you can copy it and export it and stuff like that. I have seen people before that are like analyzing web traffic, and they literally do this. And they're like, yeah, I'm analyzing Wireshark data, trying to pull out all the websites the person visited. And they're literally like going through this packet by packet. There's 542 packets here in this particular filter. Like, this is going to take years to get through. So this button is super, whoops. When you go into statistics and look at this is like super duper helpful to see what people are really going to. So, yeah. It's also, no, that's not what I wanted. This is actually even a better one. Oh, I made it angry. That was a lot. There we go. So this is even a better one to come through and figure out, like, eventually this is all, figure out the basic websites folks are going to. So, I don't think there's any other really, really cool ones for us to go to. There we go. This is neat too. So there's also the timelining going on with the flow graph. Whoops. I have upset Wireshark because it just crashed. There we go. So, seeing the timeline of what's actually going on, so it actually builds out and tries to make some basic assumptions. I wonder if it goes, yeah, here we go. So, over in the sidebar here, we see Wireshark built out an individual host is doing a query to catspin.net, and then it's saying, hey, there's a ping to that IP address. So it's actually going and trying to tie all that information together and build out a timeline for you. Just where it's also helpful to, spin out. Like, if you just do TCP, though, you're going to lose all of the, and then you're just going to be stuck with web traffic. So, that leaves the last couple things for us to do. Go back to HTTP and see this particular, I think this is actually what we left with, was looking at this IP address. So when you need to get information on an IP address, what's a good place to start? We got 54.80.141.9. What? Yeah, you could do that. You could actually go check Aaron. I always just go to CQ counter because Aaron's searching thing and it seems to always take forever. Or if you do it enough, you get rate limited by them, I think. So if we go 54.80.141.9, look this up. PUD. So are we going to figure out much about this particular host now? No, we just know it's something running at EC2. So if we filter out the actual stream, and we see it's getting v3.01 and then an IP address in reverse, which is what it looks like in the actual GET request. So when we follow this stream out, you can actually start to figure out like what would you say? How a certain piece of software is working. Anyone figure out what software this is or guess as to what software this is running on the computer? Yeah. So Sophos is running on there. What's something that Sophos does? It does antivirus and like web traffic filtering and stuff like that. So what you can actually see is as we're going along, it's sitting here sending out queries looking for, which must be like indexed data as far as like websites, and then it's returning back information on it. So this is basically the Sophos client heart beating out, looking for antivirus updates, and then you can actually see that the server is replying back with something that apparently means something to the actual client. So lastly, what's a good way to get data out of Wireshark? Like, if I have a Wireshark capture of you transferring a file, do I actually have your file?
I believe so.
Yeah. Yeah, unless it's encrypted. And I still have your file, I just can't get to it, right? So there are a few ways we can actually start to do that. If we look at the conversations, and filter out like the big one. And actually follow the stream here. Don't cross the stream, just follow the stream, right? Little Ghostbusters on your Thursday morning. I'm making this computer very angry, like it's hanging on me. Okay. So this was the biggest of all of the conversations going on. What's going on here? Yeah, someone's watching a YouTube video. So what we actually have inside of here is, like when we scroll through all of this, this is actually an MPEG video. I mean, represented in ASCII, so not super helpful. But it is getting the video data from YouTube. So has anyone ever watched a video on YouTube and then like gone into their browser cache and like, I'm gonna go get the video and it's not there? Or at least made that attempt. So the reason why, there's a couple reasons why the YouTube video is never in your browser's cache. The first one is your browser's not actually asking for the video. Who's asking for the video? Depending on how old of a YouTube we're talking about. It's actually like flash.exe or whoever. Because remember, YouTube always has a flash player. They're trying to get rid of it, but still for a lot of times we do have flash player running to get that to work. So when you go, your browser will load the flash applet inside of the window, and all you're really seeing from your browser is basically the rendering from flash. The browser then is basically passing parameters into the flash applet or the YouTube video player, and then flash is going out and getting the video. So at no point is your browser actually caching the data. Your browser is probably caching the player, but it's not caching the video itself.
So if you are using HTML5 to play the video, how does it get it into the keeping cache then?
No, it gets sent out in little bursts. And then there's another, so we'll keep going. If you're watching this nowadays, there's another reason why you're not going to see it in the cache. So I'll come back to that, or let's do that. So we can actually see, if I would go so far as to take this entire string, and this is old, so it's not actually going to work now, but if I copied this, and let's open up a text editor. So we got the string. This is the URL to actually to the MPEG video. And if I grab my host here, this is the server name. And this is, like I said, this is old, so it's, well, I assume anyway it's not going to work. It would be really cool if it did, but I'm pretty sure it's not going to. Let's put an HTTP in front of there. If I then had just done this capture and went to it in a browser, yeah, YouTube has gotten rid of that server or that server name anyway. But what Firefox would actually pop up with is like, do you want to save or run this MP4 file? And we would actually just download the MP4 directly off of YouTube. So when you go out and use like eliteyoutubescraper.com, that's all it's doing is pretending to load the video, finding the parameters for where the video is located, and just going out and issuing a GET request on your behalf. So there's not a lot of eliteness to reverse engineering YouTube. If we keep going, though, there's another reason why HTML5 stuff is going to be hard to find in your browser's cache. So this is the actual GET request from Flash going out. And if we keep going, we have here. So I made this PCAP file a long time ago. I would say round about 3 years ago. Somewhere on the whereabouts of January 10th of 2014. So what YouTube responds with, or any web server responds with, is this file was last modified on. That's the first part of what it replies with. So why would a web server tell you when the file was last changed? What does a web browser do to files it's downloading? With the exception of YouTube videos that I was just talking about. It caches them, right? Like if you open up somewhere deep in the bowels of your browser, there's files all over that your browser's cached. It's hanging on to them because then it's like, well, I don't have to download this again. I've already got it. So your browser helps you, or the web server helps you out with that by saying, here's the last time this file was modified. So at this point, if your computer is just double checking its cache and it starts receiving this, like it could actually just terminate the download now. Because it could be like, I already have that copy of the file. There's no reason for me to keep receiving stuff. It's not really how it's going to work, but more or less. The next part is it's telling you what is the content type. Why does your browser care about that? Yeah, so when your browser starts to pull down a file, it needs to know what the file is so it knows what to do with it. That is the difference between, like, assuming my little play the video thing was going to work, or download the video. If I used Safari will just load QuickTime in the background and just play the video for me. Firefox sits there and says, this is an MP4 file, it's an MPEG file coming in. I don't have a thing for that. I'm just going to save it. So different browsers make different choices based on what the file type is. Firefox will just prompt you to save it. Safari is going to load QuickTime and play it for you. That goes across like all sorts of different things. You can actually, if you have, any web server, you can actually go in and change the content types. So, like on the IA Labs IIS server, I could log in and find like files that end in .mp4. It'll literally have video/mp4 as the content tag. I could change it to be like text. But then when Safari receives a file, like, oh, it's a text file, I'll just render it to the screen. It's going to try to render an MPEG in text, and it's obviously not going to work. But it's going to give it a go. This is the next piece. Oh, so this is actually when I was visiting the website. So it's telling us this is when the file was created. So on January 10th, I apparently uploaded that video, or somewhere's about. On the 11th of February at this particular time, that's the current day as far as the server is concerned. And then expires. Why do we have an expires in here? What does that tell us to do? Yeah, like don't keep it in the cache, right? Or after this, like check to see if there's a new one. You notice what happens to match? The current day and the expiration date. So that's its like way of saying, hey, don't cache this file. Here's another one so that you know or have a rough idea. Have you ever downloaded like normally when you go to download a file, it's going to say like I've downloaded 1 megabyte of 10, right? And it doesn't, your file will be downloaded in so many times. Every once in a while you'll go to download a file and it's like I've downloaded 1 megabyte of unknown. And I don't know how long this file is going to take to download because I just keep getting data from the server and I don't know how big it really is. What's going on there is the server, when it replies with content, is not actually telling you how big the file is. This particular line here where it says content length, that's the server telling you like, okay, here's some data going to be coming in. I'm the web server. It's going to be this many bytes long. Some web servers don't do that. That's dumb. I don't have a reason why you would do that, but some don't. So then your whatever you're using to download stuff is just sitting there saying, I don't know, there's just data keeps coming and I'm just downloading it and I don't know how long it's going to take. Could be a minute, could be a year for all I'm aware. So this is a very important thing. And then as we keep going, there's our actual data. So we could switch this around and actually look at, oh, that made it mad. There we go. We could look at the actual hexadecimal data which is starting right here, and export out these lines to a file. And Wireshark crashed again. I've made it very angry today. Oh, geez. What is tipping over? Well, let's just open it again while we're having fun, right? There we go. So we could try to like rip out the file manually that way, or you can actually go to File and say Export Objects, and Wireshark basically has modules loaded that understand a few different protocols. So what's TFTP? Yeah, it's file transfer. It's usually used by what kind of devices? Routers and switches and like network gear, right? They're usually using TFTP. So Wireshark understands TFTP and can extract data out of it. How about SMB? Yeah, so that's server message block. If you use Samba or like Windows file shares, that's going to be an SMB exchange. So when you are connecting to a file share somewhere and you're downloading a file off that file share, if you capture that network traffic, you can actually extract the files that they're downloading out of it. It's really like frighteningly easy to do. The last one that Wireshark knows how to extract is HTTP. So we'll see how we do with this one. So inside of here, we have lots and lots of files, right? We could, if we want to go after DSU's CSS, we could actually extract the files out. Let's just save them all. I don't know if I want to actually do that. That's going to be a bunch of crap. So let's grab this forward slant here and hit save. There we go. Now if I go look on my desktop, I'll open that in Sublime. There we go. So we've actually can go in and just extract out the data of like the HTML of our homepage. In theory, there have been a couple bugs in here. And it appears as though they may still be here because the sorter isn't fixed yet. Obviously there's bugs since Wireshark keeps crashing on me, right? Yeah, that's not what I want. So what I was going to show you is that I should be able to actually extract out the YouTube video, but all it has is an audio file, which I don't actually know what that is. So there's another way we can do this. Another neat tool is called Network Miner. So Wireshark is probably like your deep down. Oh, good, it's a Yahoo search, the best of all of the searches. So Network Miner is really good about extracting out files and getting really basic information from network traffic. So does it want, yeah, it's going to want to be extracted. So if you go download the Network Miner free version, and open her up. You should be able to take that capture file and open it in Network Miner. Oh, geez. Network Miner, you have to buy the professional edition to open PCAP next-gen files. So you know how we get around that? Yeah, we go to Wireshark and we go Save As. And in the file type, we just make sure it's PCAP and not PCAP-NG. Did I make sure to save all of the files, or did I just save one packet? I think I saved all of the files. Let's try it. There we go. So that saved us $900 by going File Save As. The downside to Network Miner that you will quickly find is she's a little slow, especially if you open up really, really big files. If you're trying to scrape out data from a file using Network Miner, you probably want to go into Wireshark and trim it down first, because otherwise Network Miner is just going to like implode on you when it tries to open up all this stuff. As we can see by my poor virtual machine is just like, please no. There we go. So this is a other good like forensically kind of thing to see what's going on. The other kind of neat thing is that it gives us a pretty quick and easy like heads up as to what's going on with different files. So between like, what does it have, the DSU favicon right there? So when it sees you go out to a particular host that's a web server, it'll use the favicons, or it'll also try to identify the operating system. So we get a little penguin sitting right there. So that's all good stuff. It used to, oh, there we go. Tries to scrape out credentials as well. So if there's some really obvious protocol that's exchanging data in the clear, it will like auto try to scrape them out. It's also is going to miss a few things every once in a while, because here it's basically just taking cookies, which in the grand scheme of things, can you do a lot with a cookie? Yeah, you can do a ton of stuff with a cookie. What's an example of something nasty you could do with a cookie? Yeah, if you had a cookie of me going to like, I don't know, my Gmail account, you could just pleasantly plop that cookie in your browser and you're more or less going to be good to go. Because Gmail put that cookie in my browser as a way of saying, hey, they're still logged in. Which is why you can navigate away from Gmail and come back to it. Google's actually pretty good about that, so it'd be a little harder with Google. But most other websites you log into, if you steal the cookie, you'll be good to go. Luckily, you're not going to be able to get into my YouTube or Gmail account because these cookies are 3 years old. And I would assume that Google expires them after a year or two, right? All of our great DNS queries going on here. Then all of the pictures that it finds, and then we should just be able to get a file list, which you should be able to sort, but only one way, which is always cool. There we are. So I'm not entirely certain why Wireshark did not extract this for us, but we should be able to open the file. So what that comes down to is, yes, if you have a Wireshark capture of someone's data, you can get all the files out of the data, including a YouTube video. And then to make sure no one gets mad because I'm stealing crap off YouTube, that's my video, so I can steal it if I want to. So, does anyone have questions on like stripping out data, sorting through data, playing with Wireshark, all that good stuff? So there's an assignment currently out there that's like our go through DakotaCon video, stuff like that. probably, I don't know, maybe next week we'll post another assignment that'll basically be our PCAP scavenger hunt, kind of like we had our Splunk scavenger hunt of go find information about hosts and whatnot. We'll have a PCAP file that's going to go through and extract information about what's going on and find stuff on network. Usually, in my life of when I've gone and had the opportunity to pull network traces and do reports on them, there's usually not anything very exciting going on inside of them, because it's like, yep, the computer's antivirus is phoning home. You thought you found malware. It's semantic, downloading updates. So sorry, not your red flag here. So that was a fun little, what would you say, consulting gig where I'm like, nope, you didn't find something awesome. You definitely found your own antivirus software running here. So stuff like that. Although antivirus software, when it's pulling out, does usually look really sketchy, just kind of like the Sophos stuff did when we looked at that. But anyway, that's what we'll have. And I think that's what I've got for today. It only took Wireshark crashing like 4 times to get through it too, right?